today's lab, we are going to do an acid-base extraction. We've already done an extraction that was considered a neutral extraction when we removed the trimyristin from nutmeg. And in terms of the neutral extraction, we didn't need any help getting the substance we wanted to remove from the nutmeg into our organic layer, which was the diethyl ether. In this case, we're using a mixture of 3 different substances, and I went ahead and weighed them out, and they're in this Erlenmeyer flask. And the mixture contains around 0.5 grams, I'll give you the exact amounts in just a second, but close to 0.5 grams of benzoic acid, which is a crystalline solid, white crystalline solid. We also have close to 0.5 grams of p-nitroaniline, which is the more brownish yellow substance there. And then we have close to 0.5 grams of naphthalene, which is another white crystalline solid. So in terms of this, what we're going to do initially is to add dichloromethane to this mixture, and we're going to stir that until everything dissolves. The dichloromethane will dissolve the benzoic acid, it will dissolve the naphthalene, and also the p-nitroaniline. The question is, once they're dissolved in the dichloromethane, how do we remove it from the dichloromethane? Well, the naphthalene, which is a neutral compound, will not react with acid or base, so it will always stay within the organic layer. If we were to add acid to the organic mixture, then we have to think about what reacts with acids. And the substance that we have in this mixture that would react with an acid would be the p-nitroaniline. Aniline is an amino, has an amino group on there, on its structure, or within its structure. And amino groups are very similar to ammonia, NH3, which has basic properties, if you will. So if we were to add acid to the mixture, we can remove the p-nitroaniline because it would rather go with the acid than stay in the organic layer. How do we remove the benzoic acid? It is an acid. Acids love to react with bases, so what we can do is add a sodium hydroxide solution to that, and then the benzoic acid would now leave the organic layer because it would much rather react with that sodium hydroxide than stay within the organic layer. So once we separate them in different solutions, then we'll have to go back and isolate them from that solution, and that's kind of a step-by-step procedure that we'll go as we get to that point. So the first thing I have to do is to take my mixture of the benzoic acid, p-nitroaniline, and naphthalene, and add around 40 ml of the dichloromethane to that, and then we're going to let that stir until everything dissolves. This is not all the equipment, but this is what we need to get started. We're going to do everything in our separatory funnel as far as doing the extraction. Remember, this has already been greased. We have a stopper here. Very important that you grease that stopper before you begin. Always make sure this is pretty snug. You don't want it very loose. And before you pour anything in here, make sure that stopcock is completely perpendicular to the separatory funnel. That means it is closed. We will need a few flasks to collect the aqueous base, the aqueous acid, and also the neutral layer. Graduated cylinders that we need to measure out the aqueous acid, the aqueous base, and the dichloromethane. When we do the extraction, we need to make sure which layer is which. And if you have trouble with that, I've got some test tubes and a pipette. There's another type of test tube test that we can take a look at in terms of how to distinguish one layer from another when you're doing extractions. While this is stirring to dissolve, I don't need to add any heat to this. I'm just using the magnetic stir bar to facilitate the dissolution. But I wanted to show you what these individual substances look like initially. This is our benzoic acid, and you can see a white crystalline solid. And the benzoic acid, I used 0.504 grams of that. Here is the p-nitroaniline or 4-nitroaniline. It has that kind of yellowish or brownish yellow appearance. And for the p-nitroaniline, I used 0.502 grams. And then the last substance we're going to have in our mixture is naphthalene, and it's a white crystalline solid as well. And for the naphthalene, I used 0.508 grams. Naphthalene, if you've ever smelled mothballs, that's the smell of mothballs. I'm sure you've smelled that before. So I'm just going to let that stir for a little bit. It may take a few minutes for all of that to dissolve. And then once it's dissolved, then we'll actually start our separation process. All of the three components, organic solids, have dissolved in the dichloromethane. I'm going to remove the stir bar and set that aside. And then what I'm going to do is to pour, but just want to make sure we go back. Always make sure that your stopcock is perpendicular. This is closed. I'm going to pour this mixture into the separatory funnel. And then the first thing we're going to do is to take the 3 molar HCl and add it to the components, this mixture, the organic substances inside the separatory funnel. A lot of times when you do extractions, usually rule of thumb is at least twice, sometimes 3 times. We're going to use 3 15 milliliter portions of the hydrochloric acid. And we're going to use another hydrochloric acid solution later when we want to isolate the substance from the aqueous base. Make sure you always double check. We want 3 molar to do the extraction process. We'll use something more concentrated when we do the precipitation process. So I'm going to pour 15 mils. We're going to do this 3 times, but we can't do it all at once. So I'm going to use 15 mils first to pour into here. Stopper it, we'll shake, vent, and then we'll see the layer separate. Let's give it always a rotation, and make sure that when you do the venting, you want to make sure that you have your finger over the stopper. You want to give it a little bit of a swirl, and then vent, vent, vent. Usually 3 times is pretty good. Now what we're going to do is we're going to let this sit for a second. I'm going to add a little bit more of the hydrochloric acid. I'm seeing a little bit of a suspension that's in there. Let's see if this will help take care of that. And it could just be an artifact of the quality of the p-nitroaniline that we're using. It looks like it's coming from the p-nitroaniline, but I just want to kind of see if we can take care of that. If not, it will just kind of come through with and don't notice, I'm just going to let it sit there for a couple minutes and see if some of that filmy material will dissipate. There still seems to be some of that, almost looks like mucus type substance that's in between where the organic layer and the aqueous acid layer is. Now let's think about what's happened here. If I add acid to the organic solution that had the benzoic acid, the p-nitroaniline, and the naphthalene dissolved in it. Naphthalene isn't going to react with the acid because it's a neutral compound. The benzoic acid will not react with the acid because it is an acid, and acids don't react with acids. Acids only want to react with bases. So if I take a look at the p-nitroaniline, it does have an amino group that's very similar to ammonia. If you were to react ammonia with HCl, you would form a salt. And that's exactly what happens with this compound. We're reacting the p-nitroaniline, that NH2 group is analogous to the NH3 of ammonia, so it will form a type of ammonium salt. So what we have to figure out now is which layer is what. So what I'd like to do is do a little test tube test so that if there's ever any doubt, you can always do this to figure out what your layers are. So what I'm going to do is I'm going to take, and it doesn't really matter which layer you focus on. I usually do the top. If you want to go down to the bottom, just make sure you squeeze this before you put the pipette into the mixture. So I'm just going to kind of go and take just a little bit of this top layer off, and then I'm going to add it to a test tube. And then what I'm going to do, because what I'm trying to find is who's the aqueous layer and who's the organic. And I'm going to add some distilled water to that. And I'm just going to use the pipette to mix everything together. And as you can see, there is only one layer in that mixture. So what does that tell me? If I add water to the top layer and it dissolves in water, then it must be the aqueous layer. So I know the top layer now is my aqueous layer. I'm going to be more specific and say aqueous acid layer, because that's where the water came from, was from the addition of the HCl. Now I'm not wasting anything, because I can certainly take this back and pour it back into my separatory funnel, and I have wasted nothing. So I'm not wasting any material when I do that. So now, if the top layer is the aqueous acid, then the bottom layer must be the organic. So what I'm going to do, and I know the organic is neutral at this point. So I'm going to take this 125 Erlenmeyer flask, and I'm going to place it underneath the separatory funnel, and I'm going to open the stopcock, and I'm going to collect this bottom layer, which is our methylene chloride, or dichloromethane, same thing, that contains the naphthalene and also the benzoic acid. I'm going a little bit, I mean, you could go a little bit faster. I'm going a little bit slower. I'm just keeping my eye on this kind of black mucus layer here. That isn't uncommon in some cases. Sometimes you will form a type of emulsion that is in between the two different layers. Sometimes what we'll do to that is to add sodium chloride to that. I don't really see the need of doing that now, since we are going to precipitate these later. I'm going to stop it there. Now I'm just going to, since that does have a methylene chloride into that, I'm just going to stopper that just loosely until I'm ready for it again. But remember, the NO is referring to as my neutral organic. The O stands for organic, so I'm going to move it to the side. And what I want to do is to collect this material. Now remember, what did we put in here is acid. So I'm going to use the flask that says aqueous A, which stands for the aqueous acidic layer. So now what I'm going to do is to drain the rest of that. Alright, so now what I'm going to do, this is my aqueous acid. So I'm going to set it aside, and remember, never throw any flask away. What I want to wash, I don't want to put more acid. I don't want to wash this with more acid. What I want to do is take the organic and wash it with more acid to see if I can pull more of that p-nitroaniline out of this organic mixture. So I'm going to pour this back into the separatory funnel, again making sure my stopcock is closed. Save that. I'm going to keep combining that in my neutral. And then I'm going to measure out another 15 mils of the hydrochloric acid, again 3 molar. And if you go a little more, a little less, it's not critical that it has to be exactly 15. Since we are washing it 3 times. But if you are doing an extraction and you add something to it and you don't see 2 layers, then you need to think, oh wait a minute, I've got the wrong layer in there. So if you should see 2 layers, you should see 2 layers. I'm going to do the same thing that we did before. to give it a minute or so just to have time to separate the layers. Although you can see that the layers are separated fairly well, we still have that material that we see. And that could be due the p-nitroaniline, as far as where we purchase that from. Sometimes it's not 100%. It could be there might be some impurities in the p-nitroaniline as well. So now we don't have to test this again if we use the same hydrochloric acid that we used before. Remember, we said that the top layer was the aqueous layer and the bottom was the organic, so I don't have to. If you want to, you can take the time to do that test tube test again. But if the organic was on the bottom, washing it with acid, it's still going to be on the bottom each time you do that. So I'm going to remove my stopper. I'm going to take my neutral organic, and I'm going to collect the organic separate from the aqueous acid. Now notice I did let a little bit, I can tell that some of the aqueous layer went into the neutral. If I would want to stop at this point and not wash it again, I would be concerned with that. But remember what I'm going to do. I'm going to set this aside. I'm going to drain this, which is the aqueous acid, into my first flask that I collected the first extraction of the aqueous acid. We're going to put this back into the separatory funnel, add more acid to that, wash it a third time. Here's my aqueous acid layer. When you are doing an acid-base extraction, this is a chemical reaction between these different substances, so you do want to mix them very thoroughly, shake them up well. Sometimes you can tell when the reaction is complete if you're hearing very little of any gas or pressure that's coming out. And it looks like this is lighter than it was before in terms of the bottom layer, which is organic. Again, if this was the organic, the first wash, the second wash is going to be the organic now. Okay, so this is my neutral organic that still has the benzoic acid, I should say, in it. So I'm going to combine all the aqueous acidic layers. So now what we want to do is to use the sodium hydroxide. So I've got a clean cylinder, I've got my 3 molar sodium hydroxide. What I want to do is pour my organic layer back into the set funnel. Again, making sure everybody is closed. And what I'm going to do here is to measure out roughly 15 to 20 mils. I'm going to get a new clean funnel for that. Let that sit just for half a minute or so, just to allow good separation of the layers. And remember, it's just a good idea to go and identify the layers again of who's organic and who's aqueous. So I'm going to take some of the top layer off. Remember, I'm not wasting anything. I'm going to add some water to it, about as much as I have in the test tube. And then I'm just using a pipette to mix all substances together in the test tube. And as you can see, one layer. So one layer means the top layer must be aqueous since it dissolved in the water. So I'm going to, again, not waste this. I'm going to go back and pour that in. And again, if you ever have any question about which layer is which. It only takes a second to do that and you're not wasting anything again. Alright, so what I want to do is to separate the layers. Now we know that the top layer is the aqueous and the bottom is still the organic. So let's talk about what we did in terms of adding the base. We've assumed that we've already removed the p-nitroaniline because it went into the acid layer. So the only thing we would have had in the organic layer would have been the naphthalene, which is neutral, and the benzoic acid. So if we add base to that mixture and we got the two different layers, what that means is that the sodium hydroxide reacted with the benzoic acid. It pulled it out of that organic layer. So the benzoic acid now is the benzoate salt, or the salt of benzoic acid, just as if you mixed hydrogen chloride or hydrochloric acid with sodium hydroxide, you get a salt, sodium chloride. We're also getting a salt, both of which would be soluble in water. So our salt of the benzoic acid should be in the top layer, which is the aqueous. The only thing, hopefully, that's in the organic layer is our neutral compound, which would be naphthalene. So we're going to collect the neutral. So now what I've done, I've separated the bottom layer, which is the neutral. And again, now the neutral should only contain naphthalene. I'm going to set this aside for a second. So now this is our basic layer because we added the sodium hydroxide. So notice I'm going to collect it in the aqueous B, aqueous base. I can't stress enough or emphasize enough, make sure you label things, because if you go, wait a minute, what was that flask? So make sure you label everything before you start. We're going to drain all of this material, which is our aqueous base. Again, aqueous base contains the salt of benzoic acid. So all that has been drained. I'm going to close my stop pot. I'm going to save this aqueous base. Sodium hydroxide, we're probably only going to wash it twice. Previous experiments have shown that's usually sufficient. And again, the reason that you wash this or extract it more than once, it's possible that you didn't convert everything the first time, so at least doing it twice is beneficial to getting back as much as you had in that original sample. Now remember, if the organic was the bottom and the first sodium hydroxide wash, it's going to be the bottom of the second one. Here's my neutral organic. Now I can say with a fair amount of confidence that this bottom layer hopefully contains only the naphthalene. It should contain the compound that was neutral at the very beginning. Stopper the neutral organic. We're not done with that yet. We're going to come back and use that in a second. But now what I want to do is collect all my aqueous base layers. So remember, the top layer is our aqueous base. We're collecting it into the first material that we collected as aqueous base.